Hi, my name is Ben Shadraw, and today I'm going to be presenting on how to volunteer and set your withdrawal address early using Consensus Layer Withdrawal Protection, CLWP. This is EIP 4736. So Consensus Layer Withdrawal Protection is a way to broadcast validator withdrawal addresses for Ethereum, which is going to help out about 2,133 other validators in the Ethereum community by broadcasting their withdrawal addresses. Why are we doing this? Well, setting withdrawal address is good security. The CLWP community broadcast will set withdrawal addresses to as many beacon nodes as early as possible at the Capella hard fork. And this will not exit your validator, nor will it exit their validators that you're setting. But what it can do is help prevent an attacker who may have compromised the seed phrase of the validators that are in question. So if you run an Ethereum beacon node, and you don't even need to run a validator yourself, you can help broadcast these changes, and it'll help the 2,133 others that are asking for assistance because they may believe that their seed phrase for their validator is compromised. So the time to do this is between now and Capella. Capella is now scheduled for April 12th. So we're only a few days away. We would greatly appreciate the assistance. I'm going to show today how to do this on Lighthouse, but it's the exact same process if you're using Prysm or Lodestar, just with some slight differences in which port you need to connect to. Please be aware that not all beacon nodes do support advanced submissions. In particular, Teku does not support it, as do some others. But if you do need assistance to set your address, you can always use Beacon Chain's broadcast tool, which will help set it. And for the CLWP community, we've already used Beacon Chain's broadcast tool as well. If you have any questions about any of this, you can join the off-chain Discord for general advice. We also run a white hat key breach request tool where you can come and get assistance to get us with broadcasting. So how does CLWP work? Well, what we're doing is we're effectively asking a set of volunteers to broadcast these withdrawal address changes to as many nodes as possible. So if we have Alice, who legitimately wants to set the withdrawal address, normally you would send it to a single node, your own node, for example. Meanwhile, Bob would be also trying to set a withdrawal address, trying to attack Alice. By getting many volunteers and large node operators to set these withdrawal addresses as early as possible, we're able to propagate the entire network faster than potentially Bob's message could propagate at the Capella hard fork. Nothing is breaking any consensus. Ultimately, we have to wait until the Capella hard fork to start this. By hitting as many nodes as possible, we're not relying on the gossip to propagate. We're effectively seeding many different nodes at the same time. So how do you do this? First, what we're going to do is download the CLWP GitHub submissions, and we're going to then clone those to a box. This could be your validator instance, or it could be another box that has access to your beacon node. You're going to then extract ethdo, a utility that's been created by the Ethereum community, necessary to being able to set withdrawal addresses. If you're trying to set your own withdrawal address, this is the exact same utility that you will be using as well. We then unpack an offline preparation file. Now, this step is perhaps not necessary if you already have one yourself or you're running your own beacon node, but we did see that for certain types of nodes that had low gRPC message limits, that this particular file is required. If you wish, you can use ethdo to generate it yourself, or alternatively, we've given you easy steps to be able to just extract the one that we have. Finally, what you're going to do is use ethdo to connect to your node. So each beacon node client has a different default port, and it's quite possible that you've changed it yourself. But the default ports for Prysm are 3500, Lighthouse, which we'll use today, 5052, and Lodestar defaults to 9596. Again, Teku and other clients do not support advanced submissions until the Capella hard fork. So if you're running one of those clients, thanks for the interest, but unfortunately, I don't think you'll be able to help us volunteer. All you'll be doing, though, is running ethdo, saying validator credentials set. We then pass it the connection string to say which HTTP port are you running on. We're going to use localhost today, and I'm running Lighthouse, so it's 5052. By default, all of these clients use HTTP because it assumes you're not running over the public internet, but nonetheless, ethdo reminds you that this is technically insecure, and to avoid that warning, we can say allow insecure connections. ethdo is also a scripting utility, so by default, it doesn't really put out any output. So we're going to turn on verbose output and debug output to give us as much information as possible to confirm that everything is working as expected. Finally, if you want to see if your submission actually was successful, you can always query the Beacon node API, and you can then see the BLS to execution changes. This same path is the same for each of the Beacon chain clients. All you have to do is just change the server and the port to match the same one that you used in ethdo. Let's go ahead and try it ourselves. I'm going to go ahead and connect to a server. And the first thing we're going to do is copy on over that we want to check out these files. So we will first go ahead and check these files out. All right, so these files are checking on out. The next thing we're going to do is change directories on into that files that we just checked out. Okay. We can now see that we've checked out all the files from CLWP. Here are all the offline preparation files. The one we'll be using today is the mainnet file, and all of the actual CLWP submissions are found in the mainnet folder. For your convenience, we've gone ahead and combined all these individual submissions into a giant large submission. If you want to, you could recreate this file yourself, but for convenience, we've created it for you. Let's go ahead now and download the ethdo utility. By default, we're just going to put it directly on in the same path, ConsensusLayerWithdrawalProtection. All right, it has downloaded a tar.gz file, and we're going to now extract that tar.gz file into the actual executable, and you'll now see that we've extracted out ethdo. Now we're going to extract out the offline preparation file. So I'll copy that on in. You can see we're extracting the mainnet, and we need to rename the extracted file from .mainnet to just offline-preparation.json. So we'll copy and paste that on in. Okay, so now we have our ethdo utility. We also have an offline-preparation.json file. This is where all the information about the node is being stored, and these are all the change operations that we want to now set. So all we have to do is copy this command for ethdo validator credential set, but we do need to modify it, and you'll need to do so as well to change node IP to be whatever your host or IP address is for your Beacon node. In my case, I'm running it on localhost, so I'll just type in localhost. So again, ethdo validator credentials set, connection, pass in the Beacon node with your port number, say that you're allowing insecure connections, verbose, and debug to get the output. Let's run it. It found our offline JSON file because it's in the same directory as where we're running ethdo. And now it's loading that on in. It found the change operations.json, and whoa, there it goes. Those are all the 2,133 validators that you're now setting to have the withdrawal credentials specified on your particular node. Now you can have certainty that these are correct because each of these different change operations has a cryptographic signature that matches what is found. If it were invalid, the worst case scenario is your Beacon node would now reject it and nobody else on the network would accept it. There's no penalty for loading an invalid operation, and it will clearly error out if there was one to be found. This will take just a bit. While this is finishing, and there it goes, it's now done. You might wonder, well, how do I know if it actually got set? For this final step here, it does allow you to see the current state of your Beacon chain. Now, I will warn you, it's going to spit out that very, very long change operations message. Again, remember, you have to change the IP address or host name to match your own implementation. So I'm just going to replace node IP again with localhost. And there it is. Those are all the different change operations that are coming out, although it probably does sort them in a different order than when you first loaded them in. But rest assured, there are 2,133 that are there. Feel free to load in your own change operations into your node as well, and it'll help ensure that you're broadcasting your own change on out at the time of the withdrawal for Capella. So in conclusion, I want to say some thank yous. Again, thank you to Jim McDonald for creating ethdo and for all the help he's given CLWP. Special thanks as well to the ETH R&D community, the Ethereum magicians, Ethereum cat herders, ETH staker, flashbots, Claros, off-chains, all nodes, Lido Finance, and Avado, and many, many, many others that help make CLWP possible. In particular, if you have any questions regarding what to do for withdrawals, please go to ETH Staker. Their Discord is fantastic. They have an entire withdrawals channel, and they can help walk you through the process of volunteering, as well as how to set your own withdrawal credentials on your node or using Beacon Chain's broadcast tool. I really want to give special thanks as well to Lido, who has announced they're allowing their validator community to load these volunteer submissions if they wish. We'll give thanks to all nodes as well for helping ensure that they're going to load these volunteer messages on their own nodes. And Avado, who's mentioned in their documentation how to go ahead and use these CLWP submission processes. There are many, many others that I'm not thanking here, but I really want to call out everybody in the Ethereum community for making this possible. Thank you again for Tobes for helping manage our website and for all the submission requests that we received regarding compromised seed prices. So as a final reminder, please do not ever share your seed phrase. Never store it online. We can't emphasize this enough. Do not use it anywhere on a computer unless you absolutely have to, and keep that computer offline when you do it. You can make multiple offline copies, but keep them in locked locations and help notify others what your succession plan is. So that completes our steps today. Thank you again in advance for helping volunteer. If you have any questions, feel free to reach out to the various communities that we have. Bye.